Welcome to this deep dive. And hello from Special Man Academy. That's the learning hub of Special Man Global Solution.
Right. The company that helps innovators really bring their tech ideas to life.
Exactly. And today, we're diving into something pretty fundamental, software engineering.
A big one. We're going to look at what it actually is, its history, and why it's so critical today.
Yeah, and maybe you're listening because, well, it relates to your job, or you're just curious about the tech world, or maybe even thinking about a career change.
Could be any of those.
Whatever the reason, think of this as like your fast track to understanding a really key field without getting totally swamped in jargon.
That's the plan. A clear view of something that honestly runs so much of modern life, even if we don't always see it. So let's start at the beginning. What is software engineering?
Okay, right. So basically, it's about being systematic, disciplined, applying a measurable approach to how software gets developed, how it runs, how it's maintained over time.
Yeah, it's not just coding. That's a piece, but it's really about applying solid engineering principles.
Right. Like you want the software to work, obviously, but also be reliable, efficient, adaptable for the future,
Yeah.
and, not a nightmare to maintain.
Precisely. And that involves several steps. First, you've got to really understand what the users actually need.
Okay.
Then you design the architecture, the blueprint, basically, how all the parts fit together.
Hmm.
Then comes the coding, sure, but following standards, best practices, makes it clearer, more consistent.
Makes sense.
And then tons of testing, checking it does what it should, doesn't break things. And finally, yeah, keeping it running, updating it as things change, maintenance.
The engineering part really jumps out there. It
Yeah.
makes me think of like civil engineering, building a bridge.
That's a great analogy.
You wouldn't just, toss some beams together and hope for the best, right?
Yeah.
You need plans, stress tests, calculations.
Mm.
So software engineering is bringing that kind of rigor to something invisible, but just as complex, maybe more so sometimes. You need that digital bridge to be solid.
You nailed it. And it brings together a few key things. Technical skill, obviously,
Sure.
but also creativity,
Mhm.
designing smart solutions. Problem solving is huge. And because big projects involve teams, project management and just working together are essential too.
And you can totally see why that structure is needed. Imagine the opposite, just
Right.
chaos, people coding, whatever, whenever.
Oh, yeah. That leads to buggy software, missed deadlines, blown budgets, and stuff that's impossible to update later.
We've all used software that feels a bit like that, I think.
Probably.
Yeah.
And, comparing it to traditional engineering again, even though software deals with abstract stuff like code and data, not concrete,
Right, not steel and concrete.
it shares those core ideas.
Mhm.
Design, testing, optimization, making it work better. Think about, say, Facebook. Looks simple on the surface, right? Scrolling, posting.
Yeah, pretty straightforward.
But underneath, it's incredibly complex. Massive amounts of data, millions of users interacting, tons of features. Software engineering is what makes that manageable, keeps it running reliably.
Okay, got it. So that's the... Now, how did we get here? It wasn't always this formal discipline, was it?
No, not at all. To really get it, you got to look back.
Yeah.
Its evolution is tied right into the history of computers themselves.
Okay.
So back in the early days, like the 40s, 50s, software was almost an afterthought. The big deal was the hardware, these enormous, expensive machines.
Like the giant room-sized computers.
Exactly. Mostly for science, math calculations, and the software. It was often written by the same engineers who built the machines. They were coding in machine code or assembly language, super low-level stuff, talking directly to the hardware.
So very tightly coupled. Hardware and software almost one thing.
Pretty much. And programming then. It was seen more like a craft, maybe even an art. The goal was just making the machine do the task.
Just get it working.
Yeah. Let's focus on long-term use, or if someone else could understand the code later or maintain it easily.
Right. That probably wasn't the main concern yet. So when did things start to change?
The big shift started picking up steam in the 60s and 70s. Computers got more powerful, more businesses, and governments started using them.
Demand went up.
Way up. And projects got bigger, more complex, and that's when the problems really started stacking up. This whole period got called the software crisis.
Software crisis.
Yeah.
That sounds bad. What kind of problems are we talking about?
It was a mess, honestly. Projects were late, way over budget. Sometimes they just flat out didn't do what they were supposed to do.
Oh, wow.
Bugs were everywhere, sometimes causing serious issues, and trying to fix or update existing software. It was incredibly hard, super
A
expensive.
maintenance nightmare.
Totally. And there just weren't standard ways of doing things. No set processes, no real methodologies for managing big software projects. It was like trying to build skyscrapers without blueprints or construction codes.
Okay, yeah, that paints a picture. A recipe for disaster.
Yeah. Pretty much. And all these problems converging led to a really important event in 1968, a NATO conference held in Germany.
NATO. Interesting.
Yeah, and that's where the term software engineering was formally coined. It wasn't just a new name, it was a call to action, a recognition that building software needed the same kind of discipline, rigor, systematic approach as, say, civil or electrical engineering.
So bringing engineering principles to software development.
Exactly. It was a plea for professionalism and structure.
That makes total sense.
Mhm.
So the decades after that, the 80s and 90s, were they about putting that into practice, building that structure?
Absolutely. That era was all about developing and trying out ways to actually do software development better, manage projects better, improve quality.
Okay, like what?
We started seeing the emergence of different software development models, the waterfall model, the spiral model, early ideas that eventually led to things like Agile.
Right, different ways to organize the work.
Yeah. And formal methods for testing and verifying software started getting more attention, making sure it actually worked correctly. Plus, universities started taking it seriously. Software engineering became its own academic field.
So proper education, research, it's maturing.
Exactly. And the tools got better too. New programming languages like C, then C++, later Java. They offered better ways to structure code, manage complexity, build bigger systems more effectively.
Made things more manageable.
Definitely. You could say the 80s and 90s were when software engineering really came into its own as a distinct engineering field. It was finding its feet.
Okay. Which brings us more or less up to today, the 2000s onwards. And now, software feels like it's just everywhere, absolutely woven into everything.
It really is. It's not just important now, it's central. Think about it. Smartphones packed with apps, the systems running businesses, AI, even the software hidden inside everyday gadgets.
Your smart fridge.
Your smart fridge, exactly. It's all built on software. And the field has kept evolving like crazy to keep up with all this demand and complexity.
So what does modern software engineering look like? What are the key things now?
Well, Agile methodologies and DevOps culture are huge now. Focus on flexibility, collaboration, getting software out faster.
Right, faster cycles.
Yeah. Cloud computing and things like microservices are fundamental for building systems that can scale up easily and are more resilient.
Okay.
Security is massive. It has to be baked in from the start, not bolted on later.
Definitely a big concern these days.
For sure. And automation is everywhere. Continuous integration, continuous deployment, CI/CD pipelines, automate building, testing, releasing software, plus tons of tools for monitoring, managing everything.
Sounds way more automated and interconnected than before.
It is, and it's also much more interdisciplinary.
Yeah.
Software engineers don't work in isolation. They're constantly collaborating with data scientists, UX designers, product managers, business folks.
Everyone working together.
Yeah, the goal is delivering something valuable, a good experience for the user.
Okay, so we've traced the journey from craft to crisis to this complex modern discipline. Let's really hammer home why it's so crucial now. We've kind of touched on it, but let's dig in.
Well, like we said, it's ubiquitous. Your phone is a portal to countless software services. Your car, probably dozens of software systems running under the hood.
Engine, brakes, entertainment.
All of it. Online banking, shopping online, healthcare records, how kids learn in school, even sending probes to Mars. It all relies fundamentally on software.
It's staggering when you list it out. Society runs on it.
It truly does. And because these systems are so widespread and complex now, you just can't build and maintain them effectively without the structure software engineering provides.
It's too big, too complicated otherwise.
Exactly. Think about large teams, maybe spread across the globe, working on the same system. You need those standardized processes, those tools, those best practices just to manage it all. Software engineering gives you that framework.
And reliability becomes critical, right? Especially when software is controlling important things.
Absolutely critical. Think about airplane flight controls, or medical equipment like infusion pumps or pacemakers, or systems running power plants.
Yeah, you do not want bugs there.
No way. A failure in those systems could be catastrophic. Software engineering focuses heavily on ensuring correctness. Does it do the right thing? Reliability. Does it keep doing it under different conditions? And security. Resist attacks. The stakes are incredibly high.
Beyond safety, what about the sort of economic and social side?
Oh, it's huge. Software engineering is a massive engine for innovation and economic growth. Look at the giants: Google, Microsoft, Apple, Amazon. Their entire existence is based on software.
Right. Tech titans.
But it's not just them. Software empowers small businesses, startups, individuals. It lets them create new things, reach global markets. Think about how software has changed work. Remote work is possible because of it. Digital learning platforms, telemedicine making healthcare more accessible, diagnostics getting better through software. The impact is transformative.
The pandemic really highlighted that, didn't it? Suddenly, we all relied on video calls, contact tracing apps.
That's a perfect case study. Software engineers scrambled to build and scale contact tracing apps. Video conferencing became the lifeline for businesses and schools.
Kept things going.
Yeah. And behind the scenes, data analytics software was vital for tracking the virus, helping policymakers make decisions. It really drove home how essential software infrastructure is when facing big challenges.
Okay. So pulling this all together for our listeners, what are the main things to walk away with?
Okay, key takeaways. First, software engineering isn't just coding. It's a real engineering discipline. Systematic, structured, focused on building reliable, maintainable software.
Right. Discipline is key.
Second, it evolved out of necessity. The software crisis showed the old ways didn't scale. Engineering principles were needed to build the complex digital world we have now.
It solved a critical problem.
Exactly. And finally, it's absolutely essential today, not just for tech companies, but for almost every industry, every part of society. Modern life fundamentally depends on it.
And thinking ahead, it makes you wonder, right, what's next? What new challenges will software engineering face? What opportunities are out there?
Yeah, it's constantly evolving.
How will these core ideas, structure, reliability, managing complexity, shape whatever comes next in technology? Definitely something to think about. Thanks for joining us on this deep dive.